Unit 5 Cloud Technologies and Advancements. So, outcome of Unit 5: evaluate and choose the appropriate technologies, algorithm, and approaches for implementation and use of under the 5th unit syllabus topics is Adobe MapReduce, VirtualBox, Google App Engine, programming environment for Google App Engine, OpenStack, Federation in Cloud, 4 levels of Federation services and applications, future of Federation. So outcome, evaluate and choose the appropriate technologies, algorithm and approaches for implementation and யூஸ் ஆஃப் க்ளவுடு. எப்படி க்ளவுடினுடைய டோட்டல் அப்ரோச்சஸ்லாம் வச்சு அல்காரிதம்ஸ்லாம் வச்சு எப்படி இம்ப்ளிமெண்ட் பண்ணணும், இம்ப்ளிமெண்ட் பண்ணுறது எல்லாமே நம்ம இதில் டோட்டலாக இம்ப்ளிமெண்ட் பண்ணி எவாலுவேட் பண்ணி பார்ப்போம் டோட்டலாக இந்த யூனிட் டாபிக்ஸ் வச்சு யூஸிங் க்ளவுடில். ஸோ க்ளவுட் கம்ப்யூட்டிங் வித் மேப் ரெடியூஸ் Adobe. So what is cloud computing? Cloud refers to large scale internet services like Google, Yahoo, etc. That runs on 10,000s of machines. Cloud computing refers to services by this company that are external customers rent cycles of them on their clusters. Amazon EC2, Amazon S3 having a different type of particular period premium by the premium service. Attractive features: scale up to hundreds of nodes, fine-grained billing, ease of. So what is MapReduce? Data parallel programming model for a cluster for commodity machines. MapReduce means data parallel programming model for cluster of commodity machines, pioneered by Google. Process of 20 petabyte of data per day, popularized by open source Adobe projects, used by Yahoo, Facebook and Amazon. What is MapReduce used for? At Google, at Yahoo, at Facebook. At Google, index construction for Google search, article clustering for Google News, statistical machine translation. At Yahoo, web map powering Yahoo search, spam detection for Yahoo Mail. At Facebook, data mining and optimization, spam detection. Example looks like the bang over particle night. The threshold provide which type of hiccup having in this diagram. Here also the same looking down. What is MapReduce used for? In research, analyzing Wikipedia conflict, PARC, that means Palo Alto Research Center. Natural language processing, CMU, Carnegie Mellon University, bioinformatics, Maryland, particle physics, Nebraska, then ocean climate simulation, Washington. Outline: MapReduce architecture, example applications, getting started with Adobe, higher level query language, Pig and Hive, Amazon Elasticity MapReduce design goals: scalability and cost efficiency. Scalability to large data volumes, having different types of duration and different type of capacity they provided here. Commodity machines, cheap but unreliable commodity network, automatic fault tolerance, fewer administrator, easy use. So typical Adobe can communicate different types of nodes using a rack switch, aggregation switch, 8 gigabyte or 1 gigabyte. So 40 nodes per rack, 10,000 to 1,000 to 4,000 nodes in cluster, 1 Gbps bandwidth with rack, 8 Gbps out of rack, node space. Facebook 8 to 16 crores, it will be a 16 GB RAM, 8 into 1.5 TB disk. No RAID policies available here. Typical Hadoop looks like this. Challenges: cheap nodes fail, especially if you have many mean time between failures for one node 3 years. Mean time between failures of 1,000 nodes equal to 1 day. Solution: build fault tolerant into the system, so automatically it will recover. So commodity network equal to low bandwidth. The solution: push computation to the data. Programming distributed system is hard. Solution: users write data parallelly. Map and reduce functions. System distribute work. And here also the same, looking down. The file system: Hadoop distributed file system. Files split into 128 megabytes block replicated across several data nodes. Usually, name node stores metadata, file names, block allocations, etc. Optimized for a large file sequentially reads and files are append only. This is the structure of name node, file 1, file 2 in cloud. Having data nodes, the same mingle with the data for cloud numbering the file numbers. So typical Hadoop can communicate different types of nodes using a rack switch. Aggregation switch function is available. So example word count, the programming looks like this. So word count structure also look like this. This is also already saw before. So cloud computing with map reduce word count. MapReduce execution details. Mappers preferentially secure on a same node on or same rack as their input block. Push computation to maximize network use. Mappers save output to local disk before serving them to the reducer. So allows running more reducers than hash of nodes. Allow recover if reduce crasher. Fault tolerance in map reduce. If a task crasher retry on another node, okay for map because it had no dependency. Okay for reduce because map output on a disk. If the same disk repeatedly fails the job or ignore the input block. So not for fault tolerant to work, your task must be deterministic and side effect free. Fault tolerance in map reduce. If a node crashes, relaunching it current task on the other nodes. Relaunching any map that node previously ran ஏற்கனவே ஓடிட்டு இருக்குல்லையா அதை அப்படியே ரீலான்ச் பண்ணிப்பாங்க. Necessary because their output files were lost along with the crash node. Fault tolerance in map reduce. Third one, if a task is going slowly, that means struggler, launch second copy of the task on another node. Take the output of whichever copy finish first and kill the other one. Critically for performance in large clusters, everything that can go wrong will. So takeaways: by providing data parallelly, programming model MapReduce can job execution under the hood in useful ways. Automatic division of the job into task, placement of computation near data, load balancing, recovery for failures and stranglers. Outline MapReduce architecture, examples, applications. Getting started with the Hadoop, higher level query languages, Pick and Hive, Amazon Elastic